Well, then get it out so you know what you want to ask questions about.
Yeah, I ain't do it, but still.
Oh, I didn't do it, Mr. Kenny. Why is my grade so bad in your class? I don't ever do anything. I don't understand. Why do I struggle?
You know
that you got it like multiple days ago, right?
You can't share your work.
you still have put in after collaboration grades, right?
Yeah, I know. What do you think I'm going to do while y'all are doing your understanding check today?
What you gonna
If
do?
I make
Actually,
an L, sick and all them bad grades go away.
Say again.
I make an L, sick
Sure, but
and all
you're
them
missing
bad
out
grades
on
go away.
going over these practice
Hey, I'm
assignments.
staying 18 years now.
Oh, Mr.
Preston.
I'll be right back.
He vibing.
I didn't ask if he's vibing. Put the phone up.
The phone is up. He vibing.
Headphones away. Someone's phone is not up. I'll phone them.
Oh, they're mine.
Xavier, get your phone up.
I'm trying to bring the paper out.
You never ruin another man's vibe.
It's my classroom. It's time to learn. It has ruined your vibe. I'm sorry.
Is this the,
It's not my problem.
is
Yes, that's it.
this the only paper you gave me?
For the practice assignment that we're looking at right now.
Okay.
All right. Questions, comments, concerns about this?
Like, what's gonna be on the understanding check?
The things we've learned in class.
Okay, let's go with per problem.
Yeah, because I got that content you stuff last time. But
Can I throw all this
I
away?
got it at 50.3 centimeters.
You know we have a test next week on that, right? And also I'm collecting the lessons 2 through 5 on Monday, the day of the test, so I can make scans of them. Say it again.
That's for what?
Because
Who you over?
it's for me, because I'm trying to write an article about those lessons, about that unit.
And for what?
In a journal, math education journal.
I know your kid gonna be straight in there.
Other teachers are gonna read it. But I need the data so I can write about the unit well.
You went to the bathroom?
I don't know.
Alright, he went to get water, allegedly. He wasn't gone that long, so I believe him. Okay,
Let's ride with 1B.
1B? Wait, this one? I thought you said you wanted the context.
Yeah, we want both. Let's do both.
I mean, so look at it. If we're gonna interpret the slope and the y-intercept in context, what do we need first?
I mean, you already
The
know.
y-intercept? No.
You already did it from.
You already know that 50.3 is a centimeters. The height in centimeters for women, for females from 5 to 8 centimeters.
We did do one very similar to this, but,
The height is the Y.
okay. Okay, so that's what I wanted us to recognize is the height, or I really should say the dependent variable, which is y.
So why on the understanding check did they have it in here as height? Oh no, that says height and speed. Never mind.
Okay.
That's two different ones. Like.
Well, I was gonna say, actually, yeah, if we do want to look at context, we could look at this number 2. This is a different problem.
No, I ain't. I don't want to see that. I want to look at 1B. Yeah.
If the female's predicted height is 75.3 centimeters, then approximately how old are they? What would that 75.3 get substituted in for?
The Y.
The age.
The age. Well, that's age.
That's the
height.
dependent.
That's
the
height.
dependent.
Right.
Okay.
So to get substituted in for the Y.
So 75.3 is equal to 50.3,
Plus 6.
and I'll just make it x for now.
And then you do inverses?
Solve for x. You gotta
Minus
find
50.
out what makes that equation true.
Minus 50.3 minus 50. They're going to be 20.
Well, no, 20 is equal to 6.01x, right?
So they're going to be 20.
Yeah, do the multiply.
No,
Have you solved for x yet?
You're right.
they're like 12.
Not even.
I mean, that's what, no, I'm thinking.
You're dividing by 6.01.
Yeah, so 20.
So it'd be like 3.
It's like 3.
Okay, how would you interpret it?
No,
I'm talking about eight.
She's 3.
See, he's talking about 8. He's talking about 8. He's talking about
Let's look at this one, which is a completely new context. Did you ever even, oh, I already know the answer. You have not attempted to look at these yet. Mr. Kenny, I'm not going to do the work, but help me out. I will be busy. Then I'm too busy to teach you right
If
now.
you busy with the Lord, it's kind of different. I mean,
How many days have you had this practice assignment?
Hey, we doing something out of church, so
Y'all got like a little thing going on.
Hey, let me ask you a question. Who invented math?
God,
So, do you think God finds math important?
yes. No,
Not
no.
more important than him.
But my point is, you're not making it about him, you're making it about whatever your church is doing. It's not about your personal relationship with God. My point is that God created math, and if he found it important enough to create to govern the entire universe by, it's probably something that's worthy of you putting your time and effort into. You can't just use God as an excuse to get out of doing work. He also blessed you with a brain and intelligence, and he asked you to use the gifts that he's given you to the best of your ability. So, the best linear model were y hat equals 1.41x plus 12.05. Then what do x and y hat mean? That's what you were asking about earlier, right, Xavier? How to interpret these things. So, read the context again. What is x going to be? Because this is also what messed you up, right, Caleb?
Huh?
Interpreting like this? Was the x...
Is this the same as that one last time?
No. Huh? X is the height. Is there any more context we should add to that?
Y is
Height in
speed.
centimeters.
Height,
In
Centimeters.
is it?
No, in inches.
It doesn't say.
It actually doesn't say. It
But
is...
you would do inches if it's height.
Yeah, well, not necessarily. We did centimeters with the girls, but notice if we're between 70 and 80, do you think that's closer, would that be inches or centimeters?
Centimeters. Height, I mean inches.
Think about it, if someone's 72 inches tall, they're what, 6 feet?
Yeah. Inches, that makes sense.
So that makes sense,
You can be
right?
6 feet.
So they care
You're
what?
not cheap.
Dude, these are tennis players. It's a different problem. Read the context. Create a trend line that you believe best models the relationship between the tennis player's height and their fastest serve. Justify your trend line as modeling the data well. So height in inches, by the way, the height of whom?
Tennis players.
Right. Really, we should say height of tennis players. Why?
Y equals speed.
Speed, the same.
And it does specifically ask for y hat, so this would be the predicted
Predicted speed.
of what?
Their fastest serve.
Predicted speed of fastest serve.
So if you had that on the understanding shit, that's all we had to do. I'm talking about like that quick.
If you don't want to answer him, you can.
Yeah, so,
You want to answer him, man?
alright,
How you gonna say yes? You know what I mean?
cause I haven't got to it yet, Keyshawn.
To be, identify and interpret the slope of the model. You gotta identify that slope. What is it?
Slope is m equals 1.41 over 1. Divided by 1, that's Kennedy.
Now, if I'm you, what am I gonna write next to that to help me? Hey, Xavier. What am I gonna write next to that to help me interpret this?
For every year, the height of the tennis players.
Every year? That's not even a variable.
That's what.
Huh? How do we calculate slope?
Last one, I'm changing one.
So one what? We're talking about the x, which
1
is
inch.
so for
For
every
inch.
extra inch, right? For increase in inches. So there's no years here.
Right. For every inch, the tennis players' speed, the speed of the tennis players increased by 1.4.
Their speed,
Of their serve.
right? So that's what we want, right? And then also notice what detail are you missing? That really important P word. The predicted speed of the tennis player's fastest serve increases by 1.41 miles per hour, right? So then what would be the y-intercept of this problem?
0, 12.
Remember, we need a 0 and the 12.05. And so again, we always want to think about the x and the y. 0 what?
0 inches.
Okay, so
See,
if
that's
it's
so
in,
dumb. That don't make sense, Mr. Kenny.
It does.
I mean, like,
It's math, bro.
hold on one second, I'll address it in a second. Was 0 inches tall, then what?
The fastest serve. 12, 5.
Predicted.
The predicted.
I agree. In context, that doesn't make sense. But here's the thing. This isn't just about interpreting that one point. If you can interpret that y-intercept, you can interpret any point that you could ever get. So that if you were to get, I'm going to make something up, but if it was, the person was 73 inches tall, and they ended up serving 110 miles per hour, now you could interpret that, okay, if a tennis player is 73 inches tall, then it is predicted that they can serve 110 miles per hour. So it's more about understanding how to interpret a point versus interpreting the slope. And again, we talked about that this is just outside of the data and the context because, yeah, you're right, nobody would be 0 inches tall.
I didn't get that, man. I said, that's a baby.
It's not even a baby. A baby comes out of the womb, they're at least like 20 inches or so. Not 20.
No,
Not 20.
inches. How about 2?
I think. Have you ever seen a baby born? It's at least, norm is like 16 to 20, I think.
20 yards to be baby.
Not really. 2 feet?
That's like Saul, he was baby. 20 inches. Now 20 inches could be Saul, he was baby. I see it.
Alright, do you have any questions about this before I give you your understanding check?
My mama said I'm not allowed to take your test.
Okay, you can take a 0.
Yellow.
You go back over there.
I'm ready to start.
Alright, let's ride.
Let's do
Go all the way down to 5.
Quick, well, Keyshawn, you said go over how to linearize?
Yeah.
So, one of the things is, first off, if I want to linearize, what do I need to figure out about the data?
Rate of change.
The rate of change, because the rate of change tells me what type of function it would already be, right? So if I look at this right here, and one thing I pointed out to students, you have to explain how you're using it, but you can go by hand and like find out the differences, right?
It's exponential.
Okay, just assuming.
No,
Okay, we'll look at it in a second. But you could go in and find those differences by hand in the calculator, but that would take you some time. There it is. So I could do the, what is it, 66.9, is that right? Yep, 66.09 minus 98.6. And then 44.3 minus 66.09. So very clearly, is that constant additive? No. But that would also take me a while to go through it like that, right?
Me too,
So what I could do is I could make, what page would I need for that? So,
Calculate.
Listen, spreadsheet.
remember that's under list and spreadsheet. So it was 0, 2, 4, 6, 8, and 10. And what was it, 98.6? 66.09, 44.3.
29, 69, 19, 9, 13, 34.
Okay, so you can do it much quicker by, doing B2 minus B1. And you just drag it and drop it.
It's exponential.
I hear you, but we want to check through this. And you can jump to exponential, but I just want to show.
How do you do exponential again?
That's what I'm going to show you in a second. So notice if it's quadratic or cubic, we would just look at those differences, but notice, have we gotten anything that's constant yet? Not yet. So remember, the linear, the quadratic, the cubic, those all have additive rates of change, which is why we look at the difference. But what does an exponential function have? Constant multiplicative. And so what are we going to look at? Remember, if it was additive, we looked at the difference. If it's multiplicative, we're going to look at the, remember, addition and subtraction are inverses, right? So what's the inverse of multiplication? So we're going to look at the ratio to divide the two. So instead of B2 minus B1,
B2 divided by.
I'm gonna try B2 divided by B1.
That's right. That's
Now,
right.
I do have the inverse function.
Well, I don't have the inverse yet, but I know that this data right now is what type of data?
Linear. No, it's not like this.
Remember, I had to look at the ratio to find the constant multiplicative rate of change. What type of function has a constant multiplicative rate of change? Exponential. So I know that the data right now is exponential, so what can I do to linearize that?
Turn it to division.
Not turn it into division.
Don't touch that.
Don't leave your
Phone.
sound on in my class.
Don't leave your phone in
Hey,
pipes.
listen again. No, listen. If this, so notice this is the constant multiplicative rate of change. That's what I would multiply 98.6 by to get 66.09. That's what I found. So you're telling me that this data right now is exponential. I don't want it to be exponential, I want it to be linear. So what do you do to exponential to make it linear?
D1 and
That's not gonna make it linear.
How do we change? I
B2.
just want to do the inverse of it. I don't know.
That's how I find the rate of
B2 times
change.
B1.
To do the inverse, you just do the opposite. That's what
Oh, that's right, I need the inverse. What's the inverse of an exponential?
Division.
No,
Logarithm, natural
logarithm,
I
right?
forgot about that.
Yeah, I forgot about that, right? So the fact that we've identified this as an exponential set of data, I need a logarithm, and we've specifically been using the natural log.
Yeah,
What if this data was cubic, what would I do to linearize it? Cube root, right? If you can identify what type of function this is, which we like to look at the rate of change for that, then you just apply the inverse to make it linear.
Right.
Right? Yes, sir. How do they make a calculator? Like who's the first person?
No, like how does a calculator be made with all that stuff?
I mean, programming.
But like that's a lot of stuff.
It's kind of like your
Yeah.
phone. It's a program. But it's
I would
much
say-
simpler.
Hey, boy.
It's less complicated than your computer.
Go ahead.
It's much simpler. Just
Hey, boy.
numbers. I'm a man.
Okay?
Was that funny?
It's funny in the sense that none of y'all are men.
Who?
I know who it is.
Who's the man? Coleman.
So, do we need to talk about this number 5?
Let me see.
Yeah.
Oh, you get the transform.
All you gotta do is linearize the data, get B.
Well, number
No, no,
5,
that's the original, that's the original.
yeah, well, notice 5, I've given you the model for the linearized data, right? And I told you that we've taken the square root of the y values, so then what would be the transformed linear model?
Square root y hat.
Square root of y hat?
Yeah.
And I'm just gonna, for simplicity right now, I'm just gonna leave it as y. So you think it'd be this? Anybody wanna push back on that or ask a question?
Let me see. Well, I forgot.
Parentheses.
But then we gotta find what type of.
Numbers gotta be square.
Well, this is only asking for the transformed linear model. To get all the other models, I would work off of that, right? So, what would I do to this in order to get the model for the original data? Notice how that's where it's asked for y equals s of x.
Square root
Or
y
just
hat.
understand.
That's squared.
You square that.
Square root, why?
All that.
It's already squared.
Oh, square, square.
So I'm gonna square both
And then
sides.
put parentheses, square, yeah. That's the model for the original data.
So notice that's the y equaling f of x equals 3.2x plus 4.1.
Wait, so that 3.2x,
Yeah, that makes sense.
x plus 4.1, that'd be a model for original, right?
Well,
The square
squared,
is
yes.
from the original.
I gotta put y equals f of x.
You don't have to, you just have to put one of them. I like doing both because I'm showing x as the input and also clearly communicating that y is the output, but you only need one of them. Okay?
Alright, and then the inverse function is, hold up. It'd be y equals,
It'd be x.
oh, man.
Would be
It'd be x equals g y.
Remember, and yeah,
It'd be the y.
pay attention, it's x equals g of
You
y.
gotta swap them.
I just squared x
You put the input or the output is.
like this.
No, ain't this,
So if you're talking about the points and the graph, yeah, the inputs and outputs switch. But remember the way we mathematically showed that here is I literally want what x is equal to, right? How do I figure out what x is equal to?
Use inverse. Minus 4.1 both sides.
Right, so use my inverses to solve for x.
So 4.1 square root y. Y is 4.1
We're subtracting by 4.1.
equals 3.2x times,
1 divided by 3.2.
yeah,
Use that good old reciprocal.
whatever that is, just put x, we don't care what it equals.
So x equals g of y equals 1 divided by 0.32.
Well, we gotta put both of them, x equals g of y equals.
Yeah, I just see it.
Man, it's like Preston just asked that question. And the answer was,
He said y of x, he just said x, g of y.
it's the same idea.
Dad, you get my paper.
First ready, we start talking like that, you ready.
Don't erase none of it.
Mr. King, while they're taking a chance now,
Hey, boy, the class.
go to the, energy.
You must be outside your mind.
You gotta understand, I don't really plan on trying that for
That boy got his dollars ready.
Then the answer is definitely no.
Well, then I do plan on trying.
We'll see. You give me some good effort, I might let you go to the vending machine.
You said whatever we make on
Before we
the
start back to
whatever we make on the understanding check, we don't make higher on the test, and that's when we get on the test, understand check. Say this.
Wait, you get, if you do better on the test?
If you do better on the understanding check,
No.
that ain't how it works.
If you do better on the understanding check, that's your understanding check grade, but that doesn't change your test grade.
I thought you, oh, it is the other way around.
Yeah.
You do bad on the
If you-
test, but you do good on the understanding check.
No. If you do bad on the understanding check,
You do good on
and
the
you
test.
do better on the test, then the test grade replaces the understanding check grade.
Bet, say this.
Okay.
Right.
Yeah, I still talking one paper.
That's why I'm over this.
Since we got
Alright,
it.
quick, so we're good on D, because I will say that's probably the most complicated part of all this.
D is.
Alright, what-
I don't even know, I don't care about that, I'll skip that. I ain't worried about that.
I am.
Okay, teach us how to do it then.
Into the G of Y equation.
So yeah, notice that's, all I mean by a composition is G of F of X. I'm composing the two, putting them together so that F of X is now the what?
Well,
Input.
yeah.
And you can also look at F of G of Y. And so like in this case, we're not gonna work it all the way out, but what is the input function? F of X is my input, right? What's the output? What's the main function I'm dealing with?
G.
G of Y.
So notice I'm looking at that equation. And you have to be careful to make sure things cancel correctly.
Right.
Squared.
So this is called compromising functions.
This is composing functions, right? So it's the square root of y, then minus that. And so remember, if they are inverses, everything should cancel so that it ends up equaling what?
0.
X equals
X.
1.
Remember, because it's 1 times x plus 0. So notice like the square root and the square cancel each other.
Cancel then the 4.1 and 4.1.
What if I get to the end of all this and I had x plus 6?
You did
Would those functions be inverses?
No.
Either I did something wrong or they're not inverses. That make sense? Okay. Ready to ride? Yeah. Good. So we have plenty of space.
No.
One person per group.
Yeah, moving this.
Oh, my life is so hard, Mr. Kenny. I gotta walk all of 5, 10 feet.
Ready. Hey, no